Let me, that's loud before I forget. So, all right, we can, all right, unless you have like specific questions, Christine, we can just start from the top. And
Yeah,
then and then I will just like go through like some things that might happen here. So, all right, so what I will say is that if you are looking at the polar coordinate system, and so this is actually just, actually, you know what? Now that I think about it, I actually have on my computer right now like a presentation about the polar coordinate system because it you talk about it again in calculus 2, in calculus 3, probably not as much like in calculus 1, but like in calculus 2 and 3 for sure. So like that's why it's actually like important to get the basics of it down. But if, oh no, the PowerPoint is like 500 pages. That's, so it might not like load right away. So I'll just draw it for you. So let's say that you have Cartesian or rectangular coordinates, and then you have polar coordinates. And so then here is actually what happens. Oh wait, I think that the PowerPoint loaded, except that it's still like 500 slides, so I don't actually know if it will, but it's okay. All right, so in Cartesian coordinates, if you have a point right here, then this is the x-axis, this is the y-axis, this is the 0, 0, which we call the origin, and then this would be a point x and y. So that's pretty much the system of coordinates that like most people have used for most of their life, and that's like that's perfectly okay. But what I want you to notice though is in polar coordinates, then what you have is a point O, and this is actually called the uh what do you call it? The point O. So it's really, it corresponds to the origin over here, but you actually just call it the pole. So it's still labeled O because it's really origin, but they call it the pole. And then this right here is actually what you call the polar axis. And so it really is just like this part. It's just literally that same part. So it's not like an axis, like all like going both directions. It just going one direction like that. And then if you have a point right here, the same point R in theta, then here is where this is a little bit different in terms of like how things happen. So if I were to say draw a triangle right here, a right triangle, and then draw a right triangle right here, then this is a difference between this and this. To get that x and y, you're actually using this distance and that. distance, X and Y. But to get this R and theta, you're actually using this R, and then that's the theta. So you're using the same triangle for both of these, but you're using different parts of the triangle. So here you're using the X and the Y, here you're using the hypotenuse and the angle. So they're exactly the same thing, but it's just the way that you look at it is like different. So it's whether, again, like whether you want to use the two sides of the triangle to find the point, or if you want to use the angle and the hypotenuse of the triangle to find the point. So that's really where I feel like this is like the I guess a misunderstanding in a way that this happened. So then what usually happens though is that in the polar coordinate system, people, and I don't want to show you the diagram like without like showing exactly in a way what is happening here, but usually you would draw a like you would draw a circle around the graph here, and then this right here would also be the length R. So that would be R and that would be R. So that's what I am getting at. So then that's why then this is what the polar graph looks like. So like I said, I didn't really want to show it just like all at once, because it really just starts with this, but then if you want to like extend this a little bit, then this is what's going on. So I will say that this one is a little bit odd in the sense that like here's the pole 0, and then if you see these like rings along here, these should all like go into the center, but I know why they don't. It's just because it makes it like really hard to see if they do, so they just don't do it. But it really should, like all of those like should go into the center like that, so that you can tell that where the radius is at. But this circle right here will have a radius of 1, and then this circle will have radius of 2, and then this circle will have radius of 3, and so on. So this is like R is 1, R is 2, R is 3, R is 4, R is 5, R is 6, R is 7, R is 8, R is 9. So these are the like the radius of the R and the theta. So if I say, and this is actually, I'm going to print another one of these, but oh, and if you want this exact one, I put it in the folder online. It's just called Polar Graph Paper. I would say that this is not like the only one that you can use, but some of them you have to watch out for though, because they give you angles that are really odd angles. Here it has like pi over 12, pi over 6, pi over 4, like common ones that people would use. But I've seen them do like pi over 10 or something on some of them, which, you know, that in my opinion, like it makes like 0 sense. So then if you have an example, so do you have any questions, Christina? Okay, so then if you have an example where it says, so I'm going to say that it says a point has a polar coordinates of 4 and 4 pi over 3 convert to rectangular. So then what is really going on is that, remember that in polar coordinates, this isn't like X and Y, it's the R and the theta. So R and theta. So then you would go over. Now, it's really like up to you how you do this, but I would say that I would start at the pole and then go over to 4. So 1, 2, 3, 4. So that would be like R is 1, R is 2, R is 3, R is 4. And then I would go over to the 4 pi over 3. So I would go around the circle over to 4 pi over 3. And then that would be the point right here. So that would be the 4 and then 4 pi over 3. Now, then what happens is, if you can see the everything sort of like on the like the graph, like I was saying, then here's the triangle that I'm talking about here, the same triangle. So you draw the reference triangle just like before, and then you're trying to say, well, all right, if I know that this is, so if you draw this again, like without all of the, if you draw this without all of the clutter in a sense, then what you really have is this is the same problem as if it said, all right, here is a 4 pi over 3, and this is actually R is 4. So then I know that this angle right here is actually pi over 3. So then I need to find X and Y. So that's what this question actually is. And so if you think about it like that, then remember that X is going to be the adjacent side, and then the Y is the opposite side. So then if you know that angle and you know that R is a hypotenuse, then you really are just saying that, and think about it like this, that if you want to find the X or the adjacent side, then you know that X is equal to R times cosine of theta, because that's how you find the missing adjacent side. So then, or cosine of theta is adjacent over hypotenuse, and then you say hypotenuse times cosine of theta is the adjacent side, and you knew that that was X and that was R. So that's what this is. So this is just, honestly, like, believe it or not, this is just a different way of writing what you've been doing in previous chapters. So this ends up being then a r was 4, and then you have cosine of the angle there. So, oh, by the way, this is actually like where I wanted to remind you about that other thing. Where did I put it? I did want to remind you about something now, but yeah, here it is, which is this right here. And so cosine of the, yeah, 4 pi over 3 is negative a half. So then if you do that, and by the way, if you just said the pi over 3 and then you made it negative later, then that's fine. But if you do the 4 pi over 3 and say 4 times negative a half is -2, then x is -2. And then to find the y, the opposite side, then y is r sine of theta. So then that's 4 sine of 4 pi over 3. And sine of 4 pi over 3 is negative square root of 3 over 2. So then that will end up being a -2 square root of 3. So y is -2 square root of 3. So then all that would mean then is that's the x and the y. So I was looking for something, but I feel like that's all I needed to say. Yeah, so if I were to do that one, then that's all I would actually enter for that result. Then would be that this would be xy is -2 comma -2 square root of 3. So do you have any questions, Christina? Okay, so like I said, like the fact of the matter is that was actually a little bit like that was a little bit of a long-winded explanation of what's going on. But if you start with r theta, then if you want xy, then you just need to do r cosine theta, r sine theta, and then that will give you the x and the y. But it comes from the same steps as using the triangle. So you can just, at this point, like the reason why they do this is so that it gives you the opportunity to just memorize this is a formula rather than using the triangle every time. So that's actually the good thing, is that this is actually a formula you can use and you don't have to like go back to the triangle every single time. So those are those there. Now, if let's say you start with the x and the y, and you sort of yeah, if you start with the x and the y and you go and you need to change to the r theta, then this is where you have to pay attention that it says something like r is greater than 0 and theta is between 0 and 2 pi. So just be a little bit careful about that. So here is why, and it's because if you actually look at this one, so it says number 2, convert the rectangular coordinates of 8, -1 to polar coordinates with r is greater than 0 and 0 between theta and 2 pi. So sometimes, like in my opinion, like a sketch really does like help. So I can actually rewrite this so that if I have X and I have Y, then I have 1, 2, 3, 4, 5, 6, 7, 8, and then Y is -1. So it's actually just like that. This is the 8, -1, and that's X and then Y. So I know that I need two things. And one of the things I need is this is the R. And the other thing that I need is from this axis over, I need the theta. So I need to find the R and I need to find the theta. So then the R actually comes from the Pythagorean theorem. So this is 8 and this is -1. So find R using the Pythagorean theorem. So that will end up being the where is it? It's yeah, 8 squared plus -1 squared is r squared. So 64 plus 1 is r squared. And so then that will be 65 is r squared. And so it's square root of 65, but plus or minus. So I do want you to notice it's plus or minus, but you only use the positive one here because it wanted r to be greater than 0. So if it says r is less than 0 in the problem, then you need to use the one where it's less than 0. So it is possible for r to be negative, but that's not what it wanted here. So since the problem wanted the r greater than 0, then r is square root of 65. And that would be, when you find it, about 8.0622577482985, or to 2 decimal places 8.06. So if you need to do that, then to 2 decimal places 8.06. But then to find the theta, then if you remember how this actually works, and this is, I really wish I remember where I put this part where I told you when to add the 2 pi or when not to add the 2 pi, or I do not remember what section that was in, because I know that we talked about all of this, like, because even if you remember, like this from a previous chapter, we had these formulas. These are the same formulas, but we're doing it in a different way now. So that's why I know that I told you the one for the, like, when you need to add the 2 pi and when you don't, but I don't remember where I put it. So if I remember, I'll tell you, but you'll be fine. I'm sure. So then, all right. So I want you to see though that for this triangle right there, then to find the theta, then remember that you know that the, where was it? I know it. Yeah, that tangent of theta is opposite over adjacent, or tangent of theta is y over x. So that is actually in this case, then since the y was -1 and the x is 8, -1/8. But if I look at that, and again, like you usually are okay with, since the problem wanted the 0 less than or equal to theta less than 2 pi, that means that you should use radians. So this is actually like one of those things where because the last chapter used a lot of degrees, if you forget to change your calculator back to the radians, it could be like something where you get a wrong answer once. So try to just remember, in this chapter, they're going to ask you to use radians again a lot of times. So if I do that, then in radian mode, oh, I don't know why you can't see that, but in radian mode, then second tangent inverse of the -1/8. So that will be, then theta is approximately -0.12435499945. But because they wanted it to be between the 0 and 2 pi, then you need to add 2 pi to it because you don't want it to be negative. So if you look at the triangle and where it's at again, 1, 2, 3, 4, 5, 6, 7, 8 in -1, then the angle that this actually gave you then was actually, there is the negative, right? That negative number, but you want it to actually be another 2 pi and go back all the way around. So you need to say, well, since it wanted that, then you can say that theta is approximately this plus 2 pi, which is then 6.1588303126328, or to 2 decimal places, 6.16. So that's to 2 decimal places. So there's that. So I don't think that this is too bad, but it's just using the formulas and in a different type of way. So do you have any questions? Okay, so then just, like if it is here, I would just write it as 8.06 and then 6.16. So that is that. Okay, so I will say that problems like number 3 and number 4 are ones where they do get people sometimes, but I really don't think it should be too bad for you. If it is, then like I hope it's not though. Then they might give you something that might look like a little bit of a trick once in a while, but it's not that bad. So, all right. So what you need to sort of actually keep in mind is that you have 2 types of problems, and one of them is that you have like number 5, right? Sorry, 3. You have polar equation 2 rectangular. And so if you do this, then the formulas for polar 2 rectangular are are going to be the, where is it? R squared equals x squared plus y squared. And then which other ones do I want to tell you about right now? Sorry, I know that. Yeah, and then tangent of theta is y over x. But if you have another problem and they say that you want to do the versus like rectangular two polar equation, then that is where you would actually use the other two that I told you about. The x is r cosine of theta and y is r sine of theta. So you're going to use like all four of those that were used to do the conversions. But instead of like just converting one point, you're going to convert an entire equation. So if it says to transform the polar equation of r is 4 cosine theta to an equation in x and y, then here is what I would do. Now again, now that I say this, I guess like I guess these actually should go in this box too, because you might actually, yeah, you might actually use these over here too. So they all should actually go in the same box because yeah, now that I say that, they probably should, because this is actually, yeah, yeah, they should all go in the same box now that I think about it. I don't know why I said that they were different boxes, but you just have to pay attention though, like I said, to which one you're doing. So this one is going from r theta to the xy's, and this one is going from xy to r's and theta. So the strategy is fairly similar. You just have to look for what is going on here. So I will say though that one thing that is a common strategy. So, oh, here, let me see. Um, uh, yeah, one of the common strategies is multiplying by r, but I really was hoping for, if you like looking for a list. So I really wish there was like a list that somebody would actually have come up with, because I swear that if I actually were to have done this myself, I probably would have. I feel like there's a reason why no one's actually given a list, because I feel like if you do it in a certain way that you could actually make things worse. So yeah, okay. So what I will say is that one of the common things is to multiply by an R. So one common strategy is to multiply by R. So if I take the r is 4 cosine of theta, and I multiply each side by r, so r and r, then I have r squared is 4r cosine of theta. And then if I look at the boxes at the top, r squared is x squared plus y squared. And then the r cosine of theta is actually just equal to x. So I can say that this is x squared plus y squared is 4x. And that would be the answer. So that would just be x squared plus y squared is 4x. So do you have any questions about that? Okay, yeah, like I said, like the easier thing to do is just like look at those 4 formulas and see like what you can do to make the problems look like what's in the box. And then number 4 then is then transform the polar equation of r squared is 2 sine of 2 theta to an equation in x and y. So this one I will say is a little bit more difficult than the last one because of the fact that right none of the equations at the top have a 2 theta in here, so you have to like rewrite the equation so that it doesn't have the 2 theta in it. So use the identity of 2 sine of 2 theta is, well, actually, just not, you don't even need the 2 right now. You don't just sine of 2 thetas, a 2 sine theta cosine theta. So then that actually gets substituted in right for here. So then we have, therefore, r squared equals 2 times a 2 sine theta cosine theta. And then if you remember what happened in the last example, we really, and this all depends on like how you like want to think about it, because you need to have a, whenever you see these like sines and cosines, you need to have an r in front of them. So you're going to actually multiply by r twice because you need a r sine of theta and an r cosine of theta. So you're going to do r times r. So multiply by r squared on each side. So this is actually r squared times r squared equal 4r sine theta, and then r cosine of theta. And then if you use the formulas at the top, and there's actually a reason why I'm not writing that as r to the 4th. You could, but this is, there's not a formula for r to the 4th, but there is for r squared. So that's why I'm just gonna leave it like that. But this was the x squared plus y squared. That's x squared plus y squared. This is y, and that's x. And so you can't, so this is like substitute the formulas, And so then this is actually x squared plus y squared squared is 4xy. And that is the final result. So I don't think that this is too bad, but they have a little extra trick in there once in a while that you have to like go back and use some of the identities like from the previous chapter. But do you have any questions? Okay, yeah, like so this is actually the polar to the rectangular, but the next ones then will be the number 5 and number 6 should be the ones. I don't know if I'll need the calculator again. I might, but I'll put it over there. But number 5 is converting from a rectangular to a polar equation. So sorry, I'm taking the phone off the hook because I'm assuming it's a spam call again. So transform the rectangular equation of the 5 x minus y equals -2 to a polar equation, and then they'll say in r and theta. So that's actually not going to be as bad as it seems. But the key here, though, is that they're always going to try to solve these for r. So, and solve for r. So if you do this, then 5x minus y is -2. Then remember that the x was r cosine of theta, y is r sine of theta. So if you substitute those in right here and then just go for it, I don't think that actually is too bad. So 5r cosine of theta minus r sine of theta equals -2. And then since you want to solve for r, then just factor out the r. And so then you have r times 5 cosine of theta minus sine of theta equals -2. And so then divide by that 5 cosine of theta minus sine of theta. So that would be number 5. And they have it right here where they say like do not like type r equals. So it would be, and then type in theta for your answer. So 5, and then I'm pretty sure that you have to do it like cosine and then theta, and then minus sine of theta like that, or else it might do something really weird otherwise. Like if you don't put the times right there, I'm being honest, like I think it does something a little bit weird because I did it the other day to double check. But do you have any questions about that one? Okay, so so this one is actually very easy. And I think it's just substituting, and then I think the ones actually before were more difficult than this one, but it just is. You have to like practice like going back and forth between the different forms. And this is important because like right now it's just rectangular and why? Oh my. Rectangular and the polar coordinates, but in calculus, you'll have like cylindrical coordinates and spherical coordinates and things like that. So it's important, to get the polar coordinates earlier on so that when you get to the other stuff, it's easier. So then 6 would be transform the rectangular equation of y is -5x, sorry, not +2. They had it really oddly print it out on my page. So 5x squared to a polar equation. And then again in r and theta, and we're going to solve for r again. So same idea here, but a little bit more tricky maybe because of the fact that it's x squared. So we'll make the same substitutions. Y is -5x squared. So r sine of theta is -5 times r cosine of theta squared. And then what I will do is I will square each side. So you have r sine of theta. Oh, yeah. And it also says assume r is not equal to 0. If you don't assume that, then the next step is actually, yeah, you can't do the next step. So that will be -5 r squared cosine squared of theta. And then normally, right, you would actually have to set it equal to 0 and have like 5r squared cosine squared theta plus r sine of theta equals 0. And then factor out the r. So r times 5 r cosine squared theta plus sine of theta equals 0. And then set each of these equal to 0. But here's the thing, right? Because of the fact that it said somewhere assume that r is not equal to 0, then you don't actually need to do that. So what that actually does for you is at this step, because since r is not equal to 0, then you can just actually divide out an r and just go like, oh, well, divide out r. And so then you can go straight to then sine of theta is what is it, like -5 r cosine squared theta. So I don't feel like it is that big of a deal, but there are cases where, yeah, like you oh, by the way, like I don't actually know if I said this, but at the beginning, but I will say that if r is 0, then it really is just the point at the pole, or the point 0, 0. So I, like yeah, it's not like typical that r would actually be 0, at least not very often, at least. So this is okay. And then from here, then if you solve for r, then that would mean that you would just divide by the -5 cosine squared theta. So sine of theta over -5 cosine squared theta is equal to r, and that would be your answer. You can simplify that using identities if you want, but I would say that I probably would just leave it like that and say sine of theta divided by -5 times, right, the cosine, and then exponent squared theta, like that, and leave your answer like that. I mean, you could simplify it if you want to, but it's not necessary. So, do you have any questions about that one? Okay, so yeah, that is actually, I think that's all of the stuff on the polar coordinates, because the rest of the problems, I will say, are polar coordinates that they give you. If you have looked like farther down the quiz, it's ones, I'll show you real quickly. Okay, let me show you, because I don't think the actual quiz actually in this case. Uh, yeah, I don't think the actual quiz like actually. Yeah, like that. I I think that the practice quiz has somewhere they have you like do some. I'll show you real quickly. They're not on the actual quiz, but for the point of like seeing what they look like, I'll like show you what I mean. But on the practice quiz, like some of the problems you just have to actually go through and adjust the slider. So if you like complete the like go like that and complete the graph, then that will enter the answer in there that you need, or the same thing. Like, so it just wants you to see the different like shapes of the like different graphs here. So that's what these are about. But I I don't think that you need to like focus too much on them, but it is important to like see like what types of things you can actually draw with the polar equations, like four leaves, uh, roses, or cardioids, or things like that. But other than that, that's all of the polar coordinates. So, you have any questions, Christina? Okay, then let me see. Let me talk about then the vectors then, since I know that we really like uh only had one day this week because of the 4th of July, so I'll try to do these vector ones today, because the vector ones actually are not going to be as bad as it seems. So number 12, once you get past the uh yeah, once you get past the whole like notational thing, it will be fine. But these are written a little bit oddly because of just the way that my computer printed them out. So if it, yeah, this is saying then, I still don't know why it printed it out this way, but if you let the vector v be 2, 4, then sketch the v and then 1/2 v. So that's what this is all saying. So I don't know why it says that like that, but I do know that if I go and I do this actually on the actual screen, then maybe I should just do the one here so that you can see how it actually works and what they want you to do. Because I think that using the actual tool isn't that bad. But so if you actually have the 4 and the -1, then All right, so the vector notation are those angle brackets, and they give you a little bit of a hint that you need to use. You need to use these, like these two angle bracket keys to get the vector notation, like the less than and the greater than signs, essentially, and that will give you the vector notation to enter for some of the later problems. But it's sort of like a point, but it's actually the line segment that is in the direction of that point. So if you start from 0, 0 and you click there, and then you go over to 4, -1, then that would be the vector 4, -1. But if you want, say, a -3 times 4, -1, then there are, oh, actually, you know what? The other one was like -3v and then 1/2 v. Okay, so that 4, -1, but this next one though, if I look at it, so there, I will say that I'm gonna draw it with my arrow on Zoom first before I use their little tool. So if I use the 4, -1, so 4, -1 is right there. But if I want the -3, then, so if I want -3 times that vector like that, then I actually need to take that vector. I don't, okay, I'm really upset at this, that it's giving me like a really hard to read color. I would rather like have, yeah, I don't know why it won't let me just, okay, why it won't let me change it to a different color now. That's just, okay, that's fine. If it doesn't want me to, then I won't like be too upset. But all right, so then if it's -3, then I have to go in the opposite direction. So 1 and then 2 and then 3 times in the opposite direction. So that's actually -3 times v, or -3 times the -1. So then my answer then would actually be like starting at 0, 0 and then draw it over to that point right there. So that's what that is actually like doing, is like taking that one and pointing it like 3 in the opposite direction like that. So if you want it to, you could actually go and like do this instead of looking at visually. You could say that it's -3 times 4, -1, and then that's -3 times, I don't know if you can see it until after I like finish typing, but I think that you get the idea that you could actually, right, just multiply each of the numbers in the brackets, or they're called components, by the -3. So you get -12, 3. And then that's what this one over here is. It's -12, 3. So I, at the very least, like, does this seem like less intimidating than it was before? Yeah, like I don't think that this is actually like as bad as it seems. You just have to like yeah,
Yeah.
yeah, it's more logical than it seems, isn't it?
Yeah, the first like question 1, like question 2 is pretty like easy, but I think the ones I have to work on the most is like question 3, 4, and 5. It looks hard because I really haven't tried them, but
Yeah.
once I try them, I think I'll be fine.
Yeah, I think so too. So like I think like even if you like go to the, oh, why will it not let me do this? Like 12, then what you do is you sketch that one, And I will say that this one actually, if you look at it, like they even like made the graph go by a half to make it easier for you. So if you do that one, then if you do 4 times a half and -1 times a half, then of course, right? I mean, it's not going to be that difficult for you to get that that's 2 and -1/2, and then you just go over to the 2, and then so you go 0 0 and then 2 -1/2, and then that's that one. So that's those types of problems. So let me see here. Let me clear that. Let me see if there's anything particularly trickier that will come down here. Yeah, so this one right here. Okay, so number like 13, I will say that maybe 13, uh, like 13 could be tricky is if you actually are not paying attention to what you're doing, because it's one of those where if you actually look at this, and this is the point where you're starting from is always called the initial point, and the point where you're ending, where the arrow is at, is called the terminal point. So then if you say call these, and this is more or less like a formula that you have to like get used to. But if you call this one, say, like x1, y1, in this one, the x2, y2, then the the whole problem is that you have to remember to subtract them in the correct order. So if they say something like this problem did, like find the position vector, then the position vector from initial point of x1, y1 to terminal point of x2, y2 is v is equal to, and it's always like x2 minus x1 and y2 minus y1. So this is one point where, like, if you subtract these in the wrong order, then that's the number one mistake that people would make on a problem like this. So other than that, I don't think that this will be a problem, but of course, if I didn't at least say that, I would feel a little bit bad about it that I didn't actually, uh, yeah, I didn't point out for you that you need to pay attention to the order that you subtract these in. But again, it's really just a formula. So, do you have any questions about that one? Okay, then
It's really easy.
yeah, this is actually not that bad. I feel like even like 15 and 16 and 17 are like, once you see the formulas, they probably will be okay for you. I think that the one where people might, I don't know, like the ones where I feel like people have gotten wrong the most are probably the last two, because they people sometimes, so I'll do the 20 and 21. And then, yeah, but I feel like if you look at 14, you should be fine at some point, but yeah, I just like, I can't really tell what's going on this. For some reason, that's like really odd that it printed like this, because I know that, yeah, these are not that difficult though, because this is saying that if like V1 is 7i minus 5j and V2 is negative 2i plus 6j, then find the 9v1 minus 4v2. So honestly, like if you think about this, though, it the I vector, or sometimes people write it with a little hat over it if you are in engineering, but that's just the vector that is 1, 0. And then the J vector is actually just the vector that's a 0, 1 vector. So like it just like special notation just for those two. So if you see I and J, that's all it really means. But you can just substitute like 9 times 7 I minus 5j, and then minus 4 times negative 2i plus 6j in, and then distribute just like you normally would, and get 56i minus 45j plus 8i minus 24j, and then combine the like components to get the, actually that's 63. I don't know why I said 56, 63. So 63i plus 8i, 71i, and then minus a 69j. So that's what would go in that box right there. So I really don't think that it's actually that difficult, but it's just looking at the formulas. But I will say that number 20. All right, where is number 20? Because I feel like this is actually one of those where, um, yeah, I do think that the the thing is actually the hardest part about a problem like 20 is that if you have a helicopter that is heading, so it says a helicopter is heading the north 79 degrees west. So that means a direction angle of 169 degrees. So what that means is that if you have north here and then east and then south and then west, then you're going like 79 degrees like north and then 79 degrees to the west. So that would be really like, here is your theta is 169 degrees. So this is going at 19 miles per hour. So that's 19 miles per hour. And then it says the wind is blowing at south 54 degrees east. So a direction angle of the 324 degrees. So that would be for the wind. north, south, east, west. So you're over here, and it's sort of, like I feel like you're 54 degrees like that way. So this right here is the theta is 324 degrees. So this is actually 9 miles per hour. And then what you want to do is actually, then if you want to find the velocity vector of the helicopter's true heading, then that means what you need to do is take the velocity is the where is it? That is the velocity of the helicopter plus the velocity of the wind. So you're going to like take both of those and then add them together. But the velocity formula is, I'm trying to make sure that I know where this is actually. Oh, yes. Okay. Sorry. It just wanted the velocity of the velocity vector. So then remember that the V will be the R cosine of theta, because it just like XY again. So we're using the R cosine of theta and R sine of theta that we used like earlier in the chapter. So that's sort of why, even though this isn't really like people won't really talk about this as being polar coordinates when it actually is. That's the issue. So they talk about this as being vectors, and then don't really like make the connection that this is like the polar coordinates representing like the velocity vector. So that's what's going on here. But if you look at this though, for the helicopter, then this 19 is the R. So you have 19, then cosine of that 169 degrees, and then the 19 sine of the 169 degrees, and then plus for the wind, the 9 cosine of 324 degrees, and then 9 sine of 324 degrees. And then if you add those together, I really don't feel like this is going to be too bad for you, but if you say add those together, then you get that V is, all right, so if you add the orange numbers together there, you get negative 11.36976. And then if you add the blue numbers together right here, the second components, then that will be a negative 1.6647. So that will be the blue numbers, the second components added together, and then this will be the orange numbers, the first components added together. So do you have any questions about that? Okay, so I don't think it's that difficult because like the information is given to you, but then if you want part B though, then the actual like speed, the speed is going to be just the magnitude of that vector right here. So the speed is the magnitude of the velocity vector. So then that will be, this is the notation for that, but it's the double bars and then the vector. That's just notation. But if you look at it though, it it will seem very, very familiar because it's really just the square root of, right, the sum of the squares of those two numbers. So if I use the numbers that are not rounded off, which is probably again like usually the safest thing to do, but it it would be, and you could use those if you wanted to, but if I use the numbers that aren't rounded off, then 3 squared plus negative 1.664693584779 squared. So if I do that, then then I would get that this is about 11.490982053228. So all that I really would say then is that this sort of magnitude of this is actually just the square root of like x squared plus y squared. I mean, it just really, all of this is really interconnected. All right, so the if the formulas seem like they're the same formulas but in different ways, that's they really are. And then the third part is finding the drift angle or the they call it the delta. So now all you need to do then is actually just look at this vector here, and then remember that the angle was theta, like, well, tangent of theta is, if you remember, like y over x. So then tangent of theta will be that number right there, negative 1.6646935847779 over the negative 11.3697635316131. And then what you do is, of course, like take the tangent inverse. So tangent inverse, if you do that, and like tangent inverse of that. So theta is the tangent inverse of that. I don't actually want to write all of that again, but I think that, yeah, I think that if I put approximately, that should be fine, because I feel like you can do that because it's about 8.33 degrees. But the issue is that if you look at what's going on though, what I really want you to see is, if you remember, V was the negative 11.36976 and negative 1.6647, right? Then that is actually here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So negative 11, and then negative 1.6 something. So actually that will be over here. So if you think about what's going on, what is if you think about what's going on though, if this was where the helicopter was supposed to be going, was like over, like if the helicopter is supposed to be going here, but the wind is blowing in that way, then the helicopter is actually going, like you see, like the helicopter is actually going in a definitely a different direction than it's supposed to be, right? Because it's not even going northwest anymore, it's going slightly like southwest. So this is the actual, like actual like like course of the helicopter here. So then what I know is that part B, this is actually the 11.490982053228 mile per hour. So that's actually the speed after the wind is like calculated in. But they're saying though that the angle is actually theta is 8.33, but that's not actually correct because you're actually in this quadrant. So you have to actually add the 8.33 degrees plus 180 degrees to be in quadrant 3. So that's how you actually know whether or not you need to add the 180 is based off of where the helicopter is actually going. So if you don't check to see where the helicopter is actually going and you forget to, add the extra angle, then that would be that could be a problem. But if I use the exact number, then it's 188.329737933744 degrees. So this whole thing is 188 point, right? So this whole red angle here all the way is 188.32973793744 degrees. But what's actually happening then is that delta that they're asking for, they actually want you to take the original like 169 degrees. That's right here. So the original like 169 degrees. And then that right here is actually the delta that they want. So the question is asking for the delta, which is the 188.3297 approximately, right, minus the 169 degrees. So that will be about 19.33 degrees. So this angle right here, that yellow one, that is the drift angle. So your answer for that drift angle then would be delta is 19.33. So I'm only pointing this out because if you got that far and then you forgot to subtract, if you got that far and you forgot to subtract them, then that would just, like I just don't know what to say at that point, so do you have any questions about that though?
For part C, are we always using tan?
Yes, so you want to use that to find the angle, the direction angle of the velocity vector. Yeah.
Okay.
So let's see. I'll do 21 because it's not, this is 21 doesn't take that long either, but it's really just a matter of like just remembering everything sort of and putting it all together. But it is like, uh-oh, I don't know what that noise is. So number 21, it says if vector v is -5, -10, and vector w is -10, -15, then you're going to do part A, calculate their dot product. And that is actually U, and then they use a little dot, sorry, V, a V, and then a little dot for a dot product, W. And then they have the part B is find the angle theta between them, meaning between the V and the W. All right, so then what you would do here then, and this is not really like that complicated of a formula, but you just have to sort of remember it as a formula. But if you have the like in general, if you have say an x1 and y1 dot a x2 y2, then that's just x1 y x1 x2 plus y1 y2. So if I have that -5 -10 dot the -10 -15, then I really just need to multiply these two numbers together and then multiply these two numbers together and then add it all together. And that's as simple as it is. -5 times -10 plus -10 times -15. And you're left with a 50 plus 150. So it is 200. So the whole thing for that one is 200. So I don't think like that formula is actually too bad, but you know, you have to see it once is all. And then here is the thing is, okay, so I want you to see this. And if V is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is the -5, -10, and then you have the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10 and -15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, -15. And then this one actually looks like this. Then, all right, so if this is -10, -15, so here's what I don't want you to necessarily get confused. It's that if I actually wanted to find this angle theta, then, or if I wanted to find this angle theta, then this is where I would use theta is tangent inverse of the y over x, or theta plus n pi, right? Where you add how many pi you need to add to get it in the right quadrant. So add pi until in theta is in quadrant 3, right? And the same idea here, theta is tangent inverse of y over x plus n pi. So same idea, like you add the theta till it's in quadrant 3. But if you want the angle between these, meaning that you have them together, right? So if you have 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one is right here. And if you have 1, 2, 3, 4, 5, so -10, and then 1, 2, 3, 4, 5, -15. So that one is actually right here. And it looks like it is now right? I mean, do you see that the actual like uh angle between them is actually very, very small, right? So this right here is the angle between them. So this is, I think that's actually, let me double check, because if I, like, I don't trust my at hand by hand drawing. That's the only reason why I'm I'm actually like, okay. So, okay, so that one is then, uh, yeah, I'm double checking my drawing, not like the actual like calculation, just the drawing, because I don't trust what I drew to be like quite like, yeah, okay. So this one, if I do this, this is actually about 236.31 degrees. And this one would be about 243.43 degrees. So this theta right here is very, very small. But all right, now here's where I would say, right, you could actually just find both of these and then subtract them. And if you say like, well, that's 243.43 minus, right, 236.31 degrees, then I would get a, right, it's about 7.13 degrees. You could do that, but another way of doing this is to do that this theta right here is cosine inverse of the v dot w over the magnitude of v times the magnitude of w. So that's where I wanted to point this out, because you because you asked me, Christina, whether it's always tangent inverse. It's always tangent inverse if you're trying to find the direction angle. But if you're trying to find the angle between the vectors, it's cosine like this. So this is like, this is for direction angle of one vector, and this is for the angle between two vectors. So I think that is what you have to sort of remember. Like, this is a formula for if you just want the angle for one vector, but if you want the angle between two vectors, it's this. So like I'm glad that you asked that, because the answer is yes, it is always tangent inverse if you're only trying to find that angle or that angle. But if you want this angle, then yeah, you could use the shortcut formula. But I don't know if it's much of a shortcut, because you see what I mean? Like, now you have to calculate other things, but uh but I I don't feel like that this is actually a lot to calculate, because you know that the magnitude of this vector here is, remember, square root of x squared plus y squared. So square root of -5 squared plus -10 squared. So that's the square root of 125. And this is right here, magnitude of that vector is square root of -10 squared plus -15 squared. So that's square root of 325. So the thing is that this is the square root of 125. This was the square root of 325. And this right up here was the answer from part A, which was 200. So that will end up being, if you put them together, cosine inverse of 200 over the square root of 125 times the square root of 325. And, like it's extreme either way, but if you want to, you could multiply under the square root and get 40,625 first, but I don't know if I would do that. But if you do that, you still get 7.13 degrees. So in all honesty, like, since you already know how to do the tangent formula, you could, like I said, just do the tangent formulas and subtract them, right? But if you want the only reason why this is here is because it's an application of the dot product, which is this guy up here. So, like, it's, I don't really consider this a shortcut, honestly, but it's up to you. So do you have any questions, Christina?
No, I don't.
Do you feel like one of these makes more sense to you than the other?
I like the second one
This
more.
one?
Yeah, the one. Yeah, I don't know why. I feel like it makes more sense to me because when you take the two coordinates like -5, -10, all you have to do is do x squared plus y squared.
Yes, exactly. So,
I feel
but
like it's more easier, like the steps, and then the top of the fraction is gonna be the one we solved in A. So you
Yep.
just do cos of -1, and then that's pretty much it.
Yeah, you're right. But I will say that, I'm sure that you can tell by now, though, like, I'm also not somebody who likes to say to memorize a lot of formulas. So
Yeah,
I go back and forth on which is the better way. But I will say that this was actually I'll put this in what I scanned, but this is like a listing of all the formulas that they have for what usually would be the final exam on campus when it's on campus, and they have the formulas that we use today all at the bottom of this, so like a summary here. So that is that. But what I will say is that I probably I yeah, I haven't actually yeah, I'm kind of torn on the final exam review, because I feel like it is one of those things where it's so long
yeah.
that
I was gonna ask you about that. The final exam is 30 questions, correct?
let me see
I think I didn't check. I should have checked before.
here. Let me see. I'm gonna